Let's learn about De Morgan's laws in propositional logic. These laws describe how negation interacts with AND and OR. The first law says not P and Q is logically equivalent to not P or not Q. The second law says not P or Q is logically equivalent to not P and not Q. So if you pay attention to it, first we are negating an AND statement. And what we're doing here is we are negating the first proposition and the second one, not P, not Q. And we are changing the AND to an OR. Not P and Q turns into not P or not Q. And the second one is very similar. We're negating an OR statement. And to do that, we are negating the first proposition, we are negating the second proposition, and we are changing the OR to an AND. Not P or Q turns into not P and not Q. Let's leave these as a reference in the corner and let's take a look at two examples. First, suppose that P means it is raining, and suppose Q means it is cold. Now, using the first De Morgan's law, let's try to find an equivalent to the sentence, it is not true that it is raining and cold. We can write this as not P and Q, right? It is not true that it is raining and it is cold. Using De Morgan's law, we know that this is equivalent to not P or not Q, which we can write as either it is not raining or it is not cold. We're using or and we're negating both P and Q. And if you think about what we're saying in plain English, it makes sense, right? If it is not true that both these things are happening, either one or the other is not happening. Let's see another example. Suppose P means the file is large and Q means the file is corrupted. The sentence, it is not true that the file is large or corrupted, can be written as not P or Q. So we are negating this OR statement. And how do we find a logically equivalent statement using the second De Morgan's law? Well, we need to negate P, negate Q, and combine them with AND. The file is not large and it is not corrupted. Which again makes sense if we think about it in plain English, because we are saying that it is not true that it is large or it is corrupted, which means it's neither, right? So the file is not large and it is not corrupted. De Morgan's laws often appear in proofs, computer programs, and even in digital circuit design. They are very useful when you're trying to reason about complex statements.